Okay, so yesterday we started talking a little bit about this in terms of these statements and the graphs that might result from it. So, first statement, number 2, the object is moving away from the origin at a constant, steady speed. Different class periods got to different places, and we got to different places in our discussion. So not everyone will have seen or heard everything I'm going to say. Some of you have actually already seen or heard some of what I'm going to do right now. So just follow along, bear with it, and we'll hopefully all get to the same place. So if the object is moving away from the origin, this is the origin. By origin, again, we mean the 0 position. So if that's the origin, away from it means this way or this way. There's only 2 ways to go away from the origin, and that would be in the positive direction or in the negative direction. So with that being said, the only ways we can really draw our lines here and be a constant speed, constant steady speed, which, remember, that translates into constant slope. So if it says constant speed, they mean constant slope on an xt graph. So what does a constant slope look like on an xt graph? Well, this would be a constant slope. Well, it's not letting me erase. Oh, that's too bad. Maybe a little, there we go. So that would be a constant slope. This would be a constant slope, only that slope is 0 slope. Let's see. This would be a constant slope. Well, sorta. It's a little curved, but you get the idea. So there's a lot of different graphs that could be constant slope. But in this case, it says constant slope or constant speed moving away from the origin. Well, there may be more than one graph that follows that. That's moving away from the origin. The positions, as this line continues to go up, the positions are getting further and further away from the 0 position in the positive direction. So that is an option. This is also moving away from the origin. Only this time, the positions are getting further away from the 0 position in the negative direction. So either of these show moving away from the origin at a constant or steady speed, since it has a constant slope. So either of those would work. Now, also, this would work. And so would this. And so would this. And so would that. Why would all of those work? Because this statement says nothing about where the object starts. It says it's moving away from the origin at a constant or steady speed. So, first of all, it doesn't tell us the direction. It also doesn't tell us where it starts. So, since it leaves those 2 details open, so again, it doesn't tell us starting position, we don't know starting position, and we don't know direction. So because it leaves those 2 open-ended, you get to pick, I suppose. So for this case, I guess, oh, tell me I can't erase these now. Apparently I can't. Now I can't erase any of those. So, oh yeah, I love these technology here. So, maybe I'll just draw one in blue. I'll keep, I'll say this one right here. That one right there is going to be my graph. So that is the line that satisfies the statement here. I'm gonna say that it starts at the origin, and that it's moving away from the origin with a positive velocity, constant positive velocity. Okay, well that's all fine and good. The point is, what does that look like over here? What does a constant positive velocity mean on this graph? How do I draw constant positive velocity on this graph? Well, this is positive up here, above the zero. Again, it's a velocity time graph. So these values here, if there were numbers, those would be positive velocities. These would be negative velocities. And because my slope over here of the position time graph is positive, my velocity over here has to be positive, which is anywhere up here. This is the positive area. Now, for the velocity to not increase or decrease, it has to stay the same. So that's what this looks like on a VT graph. It looks like a constant velocity where that is happening. The line doesn't go up, the line doesn't go down. It stays at the exact same value of velocity as time goes on. So these two graphs are saying the same thing, telling us about the same kind of motion. Now, what kind of motion map does that have? Let's see here. If we were to sketch a quick motion map, this graph right here says it starts at the origin and travels in a positive direction with a constant velocity. So that means I have to start at the origin. That would be here at the zero position. I'm going to travel in the positive direction with a constant velocity. So my arrows are pointing in the positive direction, and notice they are all about the same length. Why are they the same length? Because this object is traveling with a constant velocity the entire time. So that's number 2. 3. This says the object is standing still. Well, if the object is standing still, then that means it has no change in position. The position is not changing. It's staying at the same place. What does that look like on a graph like this? Like that. Because, again, if the line goes up or the line goes down, that means that the position is either getting bigger or getting smaller, closer to zero. Or if the object starts down here in a negative position, the position could be getting bigger in the negative direction, or it could be getting smaller in the negative direction, getting closer to zero. But in this case, it says it's standing still, so this has to be true. The position is neither increasing nor decreasing, standing still. Now, what does that look like on the velocity time graph? Well, the slope of this graph is what? The slope equals 0. A zero slope means velocity equals what? 0. So if you have no velocity, or I should say if you have no slope, you have no velocity. So what does that look like on the VT graph? Well, where is zero velocity on the VT graph? It's here. It's on this line. The t-axis is where velocity is 0. Above it, it's positive. Below it, it's negative, but on the t-axis, the velocity is 0. So, to make our graph agree with make our vt graph agree with our xt graph, this would be our line. It would literally be on the t-axis, showing us that we have no velocity as time goes on. Now, what does that look like for a motion map? Alright, so if that's our 0 position, and we have the positive direction that way, notice on the xt graph, where is my object? Well, it's not at the origin, it's not at the 0 position. It's at a positive position. Where is a positive position on my motion map? My arrow indicates that positive positions are over here on this side. Negative positions would be over here. So, I might put a dot out here in the positive position. Now the next question is, do I put an arrow on it? Well, what do arrows indicate? Arrows indicate velocity. And how much do we have? None. So I do not put an arrow on the dot because the object is not moving. No velocity. Now, how long is this happening? I would say it's happening for more than just a second. So how do we show that this is happening for more than 1 second? Well, here's how we do this on a motion map. We might show another dot right below it, and another dot right below it, and another dot right below it. All of those are in the same position. Well, how can they be in the same position? They're clearly not in the same position. They're stacked on top of each other. Well, if you remember, this is our 0 line. This is our 0 position. If you measure from the 0 position to the first dot, it's exactly the same as from the 0 position to the second dot, which is exactly the same as the 0 position to the third dot, and once again exactly the same as the 0 position to the fourth dot. All of these dots are at the same position with respect to 0. They're the same distance away from 0. And that's what the goal is here. And it shows us that on this motion map. The multiple dots show us that it's happening for more than 1 second. It's happening for a period of time. The thing about a motion map is you can't put dots right on top of each other or you don't know there's more than one dot. So we spread them out vertically to show that this object was at rest for multiple seconds. Alright, one more slide here. We've got number 4 says the object moves toward the origin at a steady speed for 10 seconds, then stands still for 10 seconds. Okay, if it moves toward the origin, we have some options here. Toward the origin means it's going toward this line here, toward the 0 position, because remember, by origin we mean 0 position. So do not forget that that's what is being referred to. Whenever you hear the word origin, they're talking about the 0 position. So how do you draw a graph where the object is moving toward the 0 position? Well, a line that goes this way is going toward the 0. Toward the 0 position. Remember, the whole line is 0, not just this point over here where the 0 is. The entire t-axis is 0. So if it starts at a positive position and does this, it's going toward the origin. If it starts in a negative position and does this, it's moving toward the origin. So again, they're leaving something out here. What are they leaving out? They're leaving out starting point or starting position, and they're leaving out what? Direction. So these are not good ways to describe motion. The ones that are on this worksheet here, they're leaving out some critical information. And all we know is that it moves toward the origin at a steady speed for 10 seconds, stands still for 10 seconds. We don't know where it starts, and we don't know what direction it's going. So I'm just going to pick one because I can, and I'm going to say that it is starting with a positive position out here, and it's moving toward the origin for 10 seconds. however long 10 seconds is on our graph. Since we don't have numbers, we just kind of make it up. So this for me, that is moving toward the 0 position for 10 seconds. And I might even make a little mark here and say, okay, that's 10 seconds. Now it's sitting still, or standing still, I guess. So it stands still for 10 seconds. Well, what does it mean to stand still? It means your position does not change. It doesn't go up, it doesn't go down. So if this is where the object stops moving, it continues to not move from that position for 10 more seconds. So we would draw that line, if I can connect it there, we would draw that line like this for 10 more seconds. So at this point now, we have an object that's moving toward the 0 position for 10 seconds. Now it's standing still for 10 seconds. How does that translate to the VT graph? Well, what kind of slope is this? Negative, right? And constant. So negative constant slope, which means what? Well, negative constant slope means negative constant what on an xt graph? Yep, velocity. Remember, the same words we're using to describe slope, those same words are describing velocity on the xt graph. So it starts with a negative constant velocity. Where is negative constant velocity over here? Well, negative velocity is down on this side. Constant means it's not getting bigger or smaller. It's staying the same. So that's what our graph looks like for the first 10 seconds. Negative velocity staying the same for 10 seconds. Then what happens? The object stands still for 10 seconds. So maybe I'll mark here that that's 10 seconds. Well, what happens after that? Well, what kind of slope do we have here? It was negative and constant. Now what is it? 0 slope. So now we have 0 slope, which means we have 0 velocity for the next 10 seconds. Where is 0 velocity? Here. It's at the origin, which is the t-axis. So that means our line for the next 10 seconds starts at 0 and goes on for 10 more seconds. So that becomes our line on the VT graph. All right, one last thing before you all fall asleep. Motion map. How do you show this in a motion map? Well, do I know my starting position? Well, they didn't tell me the starting position in my statement, but I did have to make one up for my graph. That means I started in a positive position, away from 0. So I'll start drawing my object's motion out here with a positive position. What direction is this object moving? Negative constant velocity. It's moving in the negative direction. So what direction will my arrows be pointing? Negative direction. And there will be more than one. And that happens for 10 seconds. And then what happens? I guess maybe I could draw one more. And then what happens? The object is at rest. Now it stands still for 10 seconds. So no velocity for 10 seconds means standing still. And how did that look on our last motion map? It looked like a series of dots that are stacked up on top of each other, meaning the object was now at rest for an extended period of time. Notice it is at rest before it gets back to the 0 position. Just like my graph never reaches the 0 position. So on my motion map, I also should not have the object reaching the 0 position. So there you have it. Hope that helped, and I'll see you guys soon, I'm sure.